All right, fourth grade. This is lesson, I believe 511. Let me look underneath here. 511 on page 182 of your Everyday Math Student Journal. And the instructions, which you can't see on screen, but the instructions tell you to connect two straws with a twist tie and then bend the twist tie at the connection to form a vertex. So we could do this at school, but we're not in school. So I realized tonight I don't have any straws in my house, and I'm guessing I'm not alone. But the good news is you don't need straws necessarily for this assignment. I'm just going to use a couple of pens. So this is going to become our angles. So this is basically one part of an angle, one ray, and then another here. And they want us to point both of these at 0 degrees. I'm going to tell you the point of this lesson. It's to give you an idea for how many degrees actually fit in a circle, and to give you a general idea of how many degrees do we have at a quarter turn, at a half turn, 3/4 turn, and finally back all the way around. And we talked about this briefly in lesson, I think 510. I would check, but I'm not really in position to turn my page. I have a lamp actually on the opposite page holding things down. So I'll just get down to this one. The first thing I would like you guys to do with whatever you're using, 2 pens or 2 pencils, or if you have a straw, we wanted to experiment. Down here where my finger is pointed, my left pointer finger, this is the vertex of our angles. So we're going to keep the ends of the pens in the middle at all times. But I'd like for you to bend one ray to, if this were a clock, we'd call it a quarter after. And there's a reason we call it quarter after, because it's a quarter turn. We're a quarter of the way through our entire circle. Now, the full degree measurement of an entire circle is 360 degrees. And this is what we had discussed before. And I think I mentioned in basketball, if someone comes down on a fast break and they jump and they do a complete spin in the air and then they dunk, the announcer says, "Wow, you just threw down a 360 dunk." It's because he did a full circle. So in this case, we're doing just a quarter circle. And I want you to look, if you're thinking about the angles here, the distance between my black pen and my blue pen, you should notice something about this angle. And if you're saying, "Hey, yeah, totally. It looks like a capital L, and I know those angles that are in the form of a capital L, those are right angles." And you guys should also know by this point that a right angle is 90 degrees. If you nailed that, more power to you. I'm going to get rid of that S because this is a right angle, not right angles. So if we know every time we go a quarter, we start from 0 and move our pen 1/4 of a turn, that it's 90 degrees, then how many degrees would we have if we rotate 2/4? So we started with our first turn, that was 90 degrees. And now with our second quarter rotation, it's basically just going to be 90 plus another 90. And you may know from our angle measurements earlier in the year that 90 and 90 equals 180 degrees. So this is a 2/4 turn, 2/4, also known as a half turn, guys. 2/4 is the same as a half, and that's 180 degrees. And to take you a step further, this would be a knowledge point if you were here. But anytime you have an angle that measures over 90 or all the way up to 180, we know that as an obtuse angle. And of course, anything less than 90 would be an acute. We would say it's an acute angle. But there's one more I'm going to show you here. We're going to keep rotating, and I think I'm going to run into my camera prop here, so I don't know if I can go all the way around. But this is going to be our 3/4 turn. And we've established that a quarter turn is 90 degrees. Just 1/4 turn is 90 degrees. But here we're doing 90 for one corner, 180 for a second quarter, and this is our 3/4 turn. So it's going to be 90 plus 90 plus 90. And you guys are solid with your math facts. You could do 9 times 3 is 27. Add a 0 to it, and you're going to get basically 90 times 3, which is 270 degrees. So 3/4 turn is 270 degrees. And now, of course, if you come all the way back around, that's where we end up at our full circle. That is 360 degrees. Now, one more fact. If you're saying, yeah, I knew all this, we talked about it, or you knew it beforehand, I think I have one thing I'm not sure we've talked about. So let me go back here. We know that anything under 90 is going to be an acute angle, right? So like this is less than a quarter turn, so less than 90 degrees. It looks kind of acute. Acute, acute, acute. And we know if we're right at 90 degrees, that's where we get our right angle. And we know anything above 90, all the way up to 180, that's an obtuse. But we never talked about what do you call it if you have an angle that is greater than 180, if he keeps on going past 180, beyond what a protractor can handle. Well, if it goes above 180 degrees, we call that a reflex angle. So for future reference, anytime we're going above 180, that will be, we have our little flat angle here. You notice how it starts at 0, 180 is on the complete opposite side. Anytime we go above that point, we're moving into reflex angle territory. Okay? Now, if we swing it over, if I can, this is going to take a little finagling here. Bear with me. If you look at page 183, oh boy. Okay. If you look at page 183, you're going to look at the angles below, and you're going to tell me whether it's an acute angle, a right, an obtuse, or a reflex. So you're going to have to pay attention here to the arrow that's going to show the rotation of the angle. For instance, if you look down at, this one makes sense. You can see the quarter rotation here. And we talked about what a quarter rotation was. You can tell here is that uppercase L, and an uppercase L is going to be the same as a, good job, a right angle. We know that's about 90 degrees. But the tricky one is going to be E, and we might have a few others that fit this bill. I'm going to try to focus down at E for a minute. You might be tempted to say, well, this looks like an acute angle. It's less than 90. That's clear. Here's the uppercase L, the imaginary uppercase L, and it's smaller than an L, so 90. But if you follow the rotation arrow, okay, it didn't open this way. What's actually happened is this was our starting line, and it rotated all the way around. So really, this would have been the 180 mark, but it's actually rotating beyond 180. It's going past that. It's going this way counterclockwise. Okay, so this would be an angle that would qualify as something bigger than 180, which we said is known, it's our newest vocabulary, a reflex angle. And now, as for your estimate, that's going to be kind of up to you guys. Like I said, I see that it's more than 180 degrees. This would be 180. And another quarter rotation would have brought us right about here. So this would be about 270. So I know it's more than 272. I would say you might be looking in the, I don't know, 280, 290 range. I kind of have to eyeball it there. Okay, so if you guys have any questions, anything further, you can go ahead and leave a comment, or you can email me, hit me up on Dojo, all that works. All right, guys, see ya.